Now let us refer to the question number 20. It is given that z is equal to root 3 by 2 plus 1 by 2 I whole power 5 and root 3 by 2 minus 1 by 2 I whole power 5. We should try to bring this as a complex cube root of unity by adjusting some numbers, by multiplying some imaginary numbers I square or anything. So what we want to do, we can multiply minus of I squared. I square is minus 1, minus of minus plus 1. So 1 can be split as minus I square. Some quantity has been multiplied over here by root 3 by 2 plus of 1 by 2 I to the whole power 5. Similar quantity is also multiplied over here, that is minus of I square into root 3 by 2 minus 1 by 2 into I to the whole power 5. Now in both these quantity we can take I power 5 as a common term. So if I take I power 5 commonly outside, when I take an I over here, minus of I into, we can write root 3 by 2 plus 1 by 2 into, plus, again the I power 5 is a common term for both the term, we can write minus of I into root 3 by 2 minus 1 by 2 to the whole power 5. Here the quantity I power 5 can be split up into I power 4 into I, and if I take minus 1 power 5 from this quantity, minus 1 power 5, then this will be adjusted as the complex cube root of unity as minus 1 by 2 plus of root 3 by 2I to the whole power 5 plus of this quantity is minus, this is as it is in the complex cube root unity form, I to the whole power 5. So I power 4 is 1 into I, we can write the quantity this as I, minus 1 power 5 is minus 1, so you can put minus 1, and this quantity, this is nothing but omega. We can, if you consider this as a omega, we can treat this as omega square, that is I into the quantity of minus 1 is coming with this is omega power 5 plus of this is omega square to the whole power 5. So if I multiply I into minus of omega power 5 plus of omega power 10, I into omega power 5 is omega cube into omega square. So omega cube equal 1, so minus of omega square, omega power 10 will become omega power 9 into omega, so again it will become omega. If we substitute the values of omega square and omega I into, for omega square we can write minus of minus 1 by 2 minus root 3 by 2I plus of, for omega can write 1 by 2 plus of root 3 by 2I. So on continuing this, you can see when we multiply this quantity I into minus of minus, this will become half, minus into minus plus root 3 I by 2, and expanding this is minus of plus of root 3 I by 2. These two will be eliminated. Root 3 plus 2 root 3, the 2 it will become I into 2 root 3, again I, that is I square, 2 times by 2, 2 will be eliminated, then I square will become minus 1 into root 3, or you can write this as minus root 3. We happen to see there is no any imaginary number or I or any other thing existing over here, we can conclude this is purely going on to be a real part, and its imaginary part, imaginary of given z is equal to 0. So we can conclude the answer imaginary of z equal to 0. The right choice is 4 is the correct choice.